Well, I reckon the easiest way to do this show question here is to appreciate it has a left-hand side of an equal sign and a right-hand side of an equal sign. And I reckon starting with the right-hand side and showing that equals the left is probably the easiest way. So I'm going to start with the right-hand side, which is 1 on 6x minus 18 minus 1 on the 6x plus 18. And I'm going to make a common denominator, and I wouldn't need to go to this extent in explanation, but I'm going to just take it a step further maybe than I should. I'm going to show how I'm making that common denominator, but I think that's a skill that should be obvious to markers if you sort of go straight to a common denominator and end up with the next line that I'm going to get to now. So let me just put this colour back onto there, and I get 6x plus 18 on 6x minus 18 times 6x plus 18, and minus, and then 6x minus 18 on 6x plus 18 times 6x minus 18. In fact, I would say the markers would be happy if you ended up with 6x minus 18, 6x plus 18, and you wrote the following: 6x plus 18 minus bracket 6x minus 18. If you went straight to there after your first line, so from this line here, if you went straight to that piece of working there, the markers would be happy, because that's showing that you've made a common denominator. But it is a show question, so you can't leave out too many steps. So I want to once again point out that a fraction bar is a type of grouping symbol. So, you know, it's making brackets there. That's why the brackets that I've got on the top line up here are very, very important. Because when you expand that, you get 6x plus 18 minus 6x plus 18 on 6x minus 18. Well, it's actually 6x squared minus 18 squared, isn't it? Because it's a minus b, a plus b in that denominator. So you'll get 36 on, and this is 36x squared minus 324. And if you divide by 36, you'll get 1 on x squared minus 9, which is equal to the left-hand side. So that's the way that you'd probably be expected to achieve that question. But if you were in extension 2, you would know how to make partial fractions, and you would probably be maybe just as easy to go down that road. Okay, having done that, they want us to find that integral. Well, the integral that they've given us is the same as the integral of 1 over, and sorry, I just need to go back up and see what the equivalence was, 6x minus 18 minus 1 over 6x plus 18. That's meant to be the same as 1 on x squared minus 9. So that's the integral that we're after. So we know that if we have something of the form f dash x over f of x, if we're integrating that, then we get the natural log of f of x, you know, plus c. So the denominator here has a derivative of 6. So I need to make sure I've got a 6 on the top of that fraction, but if I'm going to do that, I've got to times that by 1/6. And the same with this one. I need a 6 on the top of that fraction so that it'll have its, the derivative of the denominator is just sitting there. It's in the numerator. So I set that up. I've got a 6 out the front, the integral of 6 on 6x minus 18 minus 6 on 6x plus 18 dx. And I'll just give myself a little bit more room. That's 1/6 of, and I get ln, natural log of 6x minus 18 minus natural log of 6x plus 18 and plus C. And I'm running out of room here, but I'm going to put them together. So I end up with 1 on 6 ln of 6x minus 18 on 6x plus 18 plus C, which is 1 over 6. And if I divide the top and bottom by 6, I'll get x minus 3 on x plus 3 plus C. Now, one thing that I've not taken into account here is absolute values. You know, when you integrate, you necessarily need to have absolute values around there. So I might come back and discuss that if it becomes something in this question. But the question actually is about sketching something and finding the area. So I'd like to just move on to the question here. It says sketch this graph 36 on 2x squared minus 18, clearly indicating the location of any asymptotes and intercepts with the axes. So what I want to ask you is what happens with this function here as x approaches infinity? As x gets really, really big, we'll have 36 divided by 2 times something massive squared, take off 18. We'll get 36 on massiveness. Well, if you divide by a very, very big number, you're heading towards 0, aren't you? So going out towards infinity, we're going to be heading like that. And as x approaches negative infinity, we're going to do the same thing because we're squaring whatever the number is. So it'll be 36 divided by the same thing as when we're over on the right-hand side of the graph. So we'll end up going like that, heading towards 0. And I know it's from above, simply because when x is really big, then 2x squared minus 18 is positive, obviously. So 36 is positive, and we'll be dividing by a positive, so we'll get a positive number. So we're approaching from above. Another way people look at that is they divide everything by the highest power of x. You know, they'll say 36 on x squared on 2x squared on x squared minus 18 on x squared. And they substitute in infinity as such, right? Which is not actually an operation, but when you divide by infinity, you get 0. So they'll get 0 on 2 minus 0, which is 0. So that's a way they can see when you're approaching infinity or minus infinity, you're ending up heading towards 0 using that type of a method. So I've investigated what happens in terms of a horizontal asymptote then. And what I've got is this line going along here that they're approaching, which is the line y equals 0. All right, now vertical asymptotes, well, what can't happen here? The bottom, the denominator of the fraction, 2x squared minus 18, we do not want that to equal 0. So I'm going to put it equal to 0 to find where those things happen that we can't have, which means x squared minus 9 equals 0, so x minus 3, x plus 3 equals 0. So x equals 3 or minus 3 are going to be our vertical asymptotes. So I'll just pop them in here. There's x equals minus 3. There's x equals 3. So I've got those parts of my graph. So you can see from before what we were drawing is going to go like that. You could try sticking in a number like 4 into the original equation to see what happens, and you get 36 on 2 times 4 squared, so 2 times 16, 32 minus 18, so you get 36 on 14, and you'll see how it's well above the axis. And if you're stuck in 3.1, it'd be a long way, like the y value that would come out would be quite high. So you could just chuck a couple of points in if you weren't sure of what I've just drawn on the left and the right. Now, it's obviously an even function because function of minus x equals function of x. I noticed that when I was working out the as x approaches minus infinity, but I can see that because of the squared on the bottom. You know, like 36 on 2 of minus x squared minus 18 is the same as 36 on 2 x squared minus 18. So it's also, I could have seen that what I've drawn so far on the right and the left, I only would have needed to draw it on the right and reflect it across the y-axis to figure out what it is on the left. Nevertheless, what I'm going to do is work out where it cuts through the x-axis, the y-axis, by putting x equal to 0. So I take that, I put x equal to 0, I get 36 on minus 18 equals minus 2. So it cuts through here at minus 2. I'll just make that minus 2 there. I'll just erase that other little bit that I put. And then I can just decide what happens with this for a few points to see what goes on. For example, as it approaches 3, like say it's 2.9, I can put that in the calculator and just see what happens. And I get 36 over 2.9 squared times 2 and minus 18. And I get negative 30.5. So I get way down here. So I can see that it's heading down like that. And because it's an even function, then it makes that shape. And now I could intuitively see that as it approaches 3, then the denominator is approaching 0. So I'm going to get quite a large number when I'm dividing by something very small. And I can see that it's negative as well. Okay, so I've marked in intercept with the axis, the only one, and I've marked in the asymptotes, so I believe I've answered the question they want. And the final thing they want to do is find the exact area between the lines x equals minus 2 and x equals 2. So here's, say, minus 2, and here's 2, and those lines that they're talking about, a vertical line, we know that the line x equals 2 looks like that, and the line x equals minus 2 looks like that. So the area that we're actually after here is this area here, and because it's an even function, we can find what I'm colouring more darkly here, and we can double it, and we'll have the area of that whole piece. And we need to realise it's under the axis. So if you find the integral, you'll get a negative answer. So you want the just size of the integral in order to do that. All right. You want that the area equals twice the size of the integral from 0 to 2 of the function given. Well, because we know it's negative for sure, to turn something you know is negative into a positive, you take the negative of it. So we want that twice the negative of 36 on 2x squared minus 18 dx. Now, we've been helped by above. This is actually minus 2, the integral from 0 to 2. If we divide by 2, we get 18 on x squared minus 9 dx. And if we pull that 18 out, it's 1 on x squared minus 9 dx. And it's obvious that it can simplify that way, but also if you look at part 1, it was talking about the integral of 1 on x squared minus 9, which I've already found. I found it to be a sixth the natural log of x minus 3 on x plus 3. 1/6 the natural log of x minus 3 on x plus 3 and that's from 0 to 2. So that's minus 6, and then we've got the natural log of 2 minus 3 on 2 plus 3 minus the natural log of 0 minus 3 on 0 plus 3. And you'll notice I've popped those absolute values there like I explained before. So that's minus 6. So that's the natural log of minus 1 on 1 on 5. And that's the natural log of minus 3, so 3 on 3, which is 1. Now the natural log of 1 is 0. So this says minus 6, the natural log of 1/5. Now if you like, you can make that 6 times the natural log of 1/5 to the minus 1, because there's a log law that says you can grab a number and throw it up in front of as a power inside the log. So that's actually 6 the natural log of 5. So, or there could be other things you could do with that if you wanted to, you know, for example, you could make that 3 the natural log of 25 by taking the 2 from the 6 and popping it up as a power inside the log. All right, so if I go back up to my original here, really when I was working out the answer to this, I should have just kept my absolute values in that I'd written above there. I've already written them up there. But it actually worked out to be a very important thing, those absolute values, because you can't take the natural log of a negative, and I would have got a negative, for example, there, that without the absolute values, it would have been minus 1 on 5. But because that was made an absolute value, it becomes a 1. So it was a very important thing. All right.